I'm going to show you a way of proving a law of cosines. I honestly don't remember where I learned this proof years ago, so I would like to give credit to uh, somebody specifically, but I honestly don't remember. So uh, all I can say, it's not coming from me. I just memorized it. I learned it from somebody else. Law of cosines. Law of cosines. So I do have this triangle. It definitely is not a right triangle. Let's call this angle A. And so the side opposite, small case a. Let's call this angle B, side opposite B. And let's call this angle up here C. And so this side is going to be C. Now, if I drop a perpendicular from C, from angle C down, and let's call that H, such that makes 90 degrees. Notice that this small part right here, if I call this part X, then this part, the right part, is going to be C minus X. Okay. And what is it that we can claim about H? We can claim, looking to the left, smaller triangle, I can claim that H to the second equals to B to the second, which is my hypotenuse, minus X to the second. And looking to the right-hand side triangle, I can also claim that H to the second equals the hypotenuse A to the second minus C minus X to the second. And since we are talking about the same height, I know they're the same thing. So I can claim that B to the second minus x to the second, B to the second minus x to the second is equal to A to the second minus C minus x to the second. Now I'm going to go ahead and expand the right-hand side. So on the left-hand side, I still have B to the second minus x to the second equals to A to the second minus C squared minus 2cx plus x to the second. I'm going to go ahead and distribute the negative sign. So I'll have b to the second minus x to the second equals to a to the second minus c squared plus 2cx minus x to the second. And notice that I have minus x to the second on both sides of this equation. So by adding x squared to both sides, I just can totally cross that off. Let me go to the next page. And so now I have b to the second equals to a to the second minus c to the second plus 2cx. Okay, I'm okay with A, B, and C, but that x is bothering me. So I'm going to solve for x in terms of B. So I'm going to write solve for x in terms of B. What is it that we know? By looking at the left-hand side triangle or original drawing, I know that cosine of A equals to x over b. Remember that in the first page we had something like this, that this was my x, this was my A, this was my B, and this was my H. And we know that by definition, cosine is adjacent over hypotenuse, so x over b. Multiplying both sides of this equation by b, I get x equals to b cosine of a. Now I can substitute b cosine of a in this x up here. So this now is going to turn into b to the second equals to a to the second minus c to the second plus 2 times c times b cosine of a. Okay. Now, I'm going to go ahead and rearrange that to just isolate a squared. So a squared equals to, by rearranging, I get, or solving for a squared, I'm going to get a squared equals to b squared plus c squared minus 2bc cosine of a. And similarly, I can um, rearrange the sides and do the same thing for b squared, for c squared, and just solve for other sides and angles. So once again, this we know it as law, and of course, if you take square root of this, then a equals. I'm not going to go put plus and minus because we are talking about geometry, so I don't need the negative root. So a equals to square root of b squared plus c squared minus 2bc cosine of a. Well, I hope you like this video. Thank you.